Okay.
Yeah, so I'm sure it's just same questions, and we just kind of, so I think we can just start the quiz if you want to, and we can just work them out that way.
Okay.
All right.
I started doing it, and I kind of got stumped on a few of them.
Oh, okay.
So,
yeah, that's how I felt on maybe like a couple of them. So, yeah. All right.
Okay.
Let me just go get a pen real quick.
Okay.
Sí la vi.
Alrighty. Alright, so okay. So just let me know when you're ready.
Okay, well, I am ready.
So number 2 says, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? So we are 90% confident that the true mean heart rate is between 45 and 105. There is a 90% chance that the true mean heart rate is between 45 and 105. 90% of all people have a heart rate between 45 and 105. And there is a 90% chance that the sample mean heart rate is between 45 and 105.
So the first one?
Yeah, that's what I put.
Okay.
Okay.
Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds go no-go stimulus of males differed from that of females. The researcher randomly selected 20 females and 15 males to participate. The go-no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. So the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create 2 plots of both random samples to see if they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? It says yes, the distribution of the mean for the sample is normal since researchers can apply the Spencer limit theorem.
I think I put B, so yes, the distribution of the mean of each sample is normal since the data value has been determined to be normal.
Okay, let's see.
Is that the one you put?
Okay. I circled no. Okay. The confidence interval will be reliable. I just put no because we didn't have all the data.
Hey, you don't even know what it is.
Let's see.
The answer I got.
Because
Go to the gym, Corey.
to do the confidence level interval, you have to
You even go in California. Not once did you ever go.
know what the mean is.
I'll go with you, man. Let's go.
The mean, the standard deviation, and the sample size.
Yeah, it's wanting to know if all the requirements are met.
Is
Okay, so the requirements for the confidence interval is that a simple random sample is drawn from the population. X is distributed normally, and the standard deviation is to be known. Oh, that's for when the mean with the standard deviation is known.
yeah. Mm.
So it says that they are distributed normal. We don't know if we know the standard deviation.
Yeah, because it's not asking. I just think it's because it's not like asking whether it's like the sigma known or like when it's unknown or like dependent samples. I feel like it's just asking if it would be normal or not.
And so you think that it's the second yes?
That's what I put, but I'm not too sure on the requirements as well. Because I see the one you just read where it says there are 3 requirements that need to be checked when computing a confidence interval for mean with sigma known. And it's the ones you just read, but I don't know if
we don't know if sigma is known or not known. Huh.
Yeah.
Are the requirements for such a confidence interval satisfied? Well, the other options would be, if it was no, the distribution of the mean of each sample is not normal. Okay, we already know that it's normal, the distribution set. The other one is the company checks all the data combined is normal.
But
they've already checked.
Yeah.
Okay. So we'll do this second one, because the central limit theorem doesn't really pertain.
Yeah.
I mean,
Who? Charlie?
Yeah, that's just
Late night for
okay. All right, let's do number 4.
All right, so of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Okay, so that changes.
So let's see.
You're seeing if males differ from the females, the reaction time.
So
it would be, wouldn't it be independent samples?
Yeah, the confidence interval for the difference of means using independent samples.
Because if it was dependent, then it'd be like, say, if you had the girls and the boys, all together in one group and comparing them with their times after in a group together. But they have nothing to do with each. Well, it's the same test. They have to do each other with the test, but you're not testing the females once and then testing them again.
Yes, just
They're just comparing the two different groups.
So let's see. So the last one, right?
Yeah.
Okay. So
a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains a saving account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
So which of the following would produce a confidence interval? So I put B, obtain the balances of 90 bank customers rather than 30.
Okay,
That's what
you're dividing it by the sample.
Yeah.
Yeah, because you're dividing it by the sample size, so that would make it smaller.
Let me just take some notes here. Okay, so the next one is a factory makes propeller drive shafts for ships. A quality assurance engineer at a factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow normal distribution, with standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts.
Okay, so I went, let's see. So I took the confidence interval of 1.960 and times it by the standard deviation sigma.
Divided by the square root of 4.
Wait a minute. I did the wrong. Okay, so 1.960 times the. Well, I put standard deviation divided by the. 4. Okay, 4. Yeah, 4 was the sample size. So 2 divided by the square root of 4, which is 2 divided by 2 is 1, and then 1 times the 1.960. And then minus it from 1,000.
Yeah.
So, did you do that?
Yeah, I did that.
I got 998.040 and 1,001.960.
Yeah, that's what I got. Okay. 7. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighing is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval for you has a margin error of and positive or negative 0.0001.
Yeah.
So,
Okay, so for that one we're solving for
n.
the sample size.
Mhm.
So you went 1.960 and times it by the standard deviation divided by the margin of error. And then
Square
times it by
root.
the square root. So I got 38416.
Three. Yeah, that's right.
You want to get on?
Okay.
Yeah. Okay. The mean area of several thousand apartments in new development is advertised to be 1,250 square feet. The tenant group thinks the apartments are smaller than others. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate node measured is 5 feet high. So the null is 4, and then the other one is I think they're smaller, so it's going to be the mean is smaller. Would be the first one.
Yeah. Okay. All right. So 9. In a statistical test of hypothesis, we say the data are statistically significant at the level of significance if
Did you understand that one?
let me see.
Sunshine!
I had trouble on that one, but let's see. Yeah, it was hard to understand it, but I got either B or D.
And I put D.
Why is everything double fenced?
Okay, because it's asking the data are
No,
is significant, statistically significant.
you guys couldn't agree on the same fence?
Just trying to figure out what they're asking.
Yeah.
They have the best farm, these guys.
Because
They have that big gate right there. Park something back.
I don't know, it could be B. Because if p-value is less, then that means the data, they're significant.
Is significant to the p-value.
Huh?
So you're saying it would be significant to the p-value?
The data are statistically significant if if the p-value is less than A.
Uh-huh.
Because if it's less, then we reject the null, then that means we've got, sufficient evidence to.
Mm-hmm.
But then I'm so confused because, if it's significant, that means it's important. It's important either way if it's big or small.
Yeah. Yeah, that's why I got either B or D, but I wasn't sure. We say the data are statistically significant at the level of significance. I'm thinking B because I'm guessing that's just the rule they gave us. The p-value is less. But the p-value.
We'll put that then.
Yeah, it's just hard because the question, you don't even know what it's really asking.
I was going to go back to lesson 9 and see if it said anything. Because that's where it talks about the.
Do you want to, we can check real quick.
Okay.
Um,
Excuse me. Where's that's
were you able to find something? Let's see.
Well, I'm trying to open up the. I'm clicking on the lesson.
No, okay.
It's trying. Okay, here you go.
Charlie!
I checked my notes, but I don't have anything there.
Oh, it's 4.4. I printed all my papers except for this lesson. So. Mommy, can I have one of these? Yeah. Okay. More than little one. Or this one. I'm almost there.
Um,
Okay.
Whoa! Excuse me. Whoa!
Okay. This is all it says on the level of significance.
it's
I'll just
just,
read.
yeah.
Did you
I
read
read it. Yeah, on the,
Okay.
yeah. So it kind of just gives that rule, you know?
Yeah. Well, we'll just keep it at that. Okay, so the next one is a group of statistics students wants to determine if students in some. We're on number 10, right?
Yeah.
Okay. Some students in apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample, 15 from each of the 4 apartment buildings. If the data, this is the data for each apartment building, are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer the question? And first thing I'm thinking, no. Because it says the data is bell-shaped.
Yeah, because it has to be right skewed.
Yeah. So I was, let me see the requirements. It says the data are distributed normally in each group, and then that rule of the variance has to be met.
Why?
But it's just the F distribution.
Yeah, that's what because I thought,
Because all the data could be bell-shaped, but when you put it all together in your final test,
yeah. Because that's what I was thinking as well. Because of the same thing, the bell shape. But then I kind of thought it was A because I figured kind of what you said, like maybe towards because it is for the, those are the requirements for the F distribution. And then requirements of the ANOVA is just, it has to be normally distributed, and the variances are equal for each group.
So the first one.
That's what I thought.
Okay, well, I kind of think that too, but because I was just thinking of that bell shape, but I guess the data could be bell shaped, but then once you put it in that test and you use that hypothesis, your results won't be bell shaped. So, because you're right. I mean, they just said they got that information. Bell shaped with no outliers, and the variances are nearly equal.
Yeah.
So, number 11.
All right. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries a new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The reacher has yeah, this is the one.
Okay, so her null hypothesis was that it would be 2 years.
Yeah. Yeah.
But her results showed that it was 4.5 years. And it said that her p-value is small, so you would reject the null.
Yeah. And that's what she did. Consequently, she rejects the null.
But then in the future study shows that the treatment did not increase. So is that like saying what really happened?
Yeah.
She's saying what happened is.
So that's actually, what happened.
She rejected the null.
It would
wait a minute. In the future study, if it shows that the treatment does not increase, that's rejecting the null there too. Right?
Mm-hmm.
I don't.
Yeah, this is the one I really didn't answer.
Because it's almost doubled. Like, she had to have not used the significance level right. Or I don't know. I mean, because both of them. Even though the sample is small, the results are statistically significant, meaning it was low. Again, level.
Yeah.
Okay, so she rejected the null. She said that that it is different.
Yeah, she said the p-value was less than 0.05.
Okay, and then in the future study, it said that it isn't different. Okay, so she said that it is different. The future study says that it isn't different.
Isn't.
Okay. So I was thinking they're the same, but they're just not the same. So she is rejecting the null. I mean, she's rejecting the null, when in reality,
it was. It is true.
Because if the null is true, that means that there is not an increase. Okay, so what type? It says type 1 is committed when we reject the null. That is in reality true. So it would be a type 1.
Type 1 error.
Yeah, I knew that was coming. Wow, thanks, Corey.
All right.
Okay.
So number 12.
Well,
If the significance level is very small, thereby making the probability of committing a type 1 error very small, the probability of committing a type 2 error. I don't like this part of the lesson. I don't understand it.
I know. I didn't. I think this is just the wording of everything makes it confusing.
Okay, if the level of significance is small, making
Very small.
okay, so if it's small, you reject the null.
Yeah.
Type 1, you reject the null. That's really true. Okay. Well, if the level of significance is small, making the probability of the type 1 error small, then
Wouldn't it automatically
make type 2 probability higher?
increase? Yeah. Because it's either like it also makes type 2 smaller or makes it bigger. It's one of those.
Well, because it says right here, if the level of significance is very small, making the probability of committing a type 1 small. So if it's small, it's going to make that type 1 error probability small. Then it'd be the opposite, wouldn't it? It'd make the type 2 probability higher.
Yeah.
That'd be the last one, but reducing the probability of committing a type 1, we increase the probability.
Yeah.
Hope that's right.
Yeah. Let me mark the ones we're not too sure about. Okay. All right. So 13. 13. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5. The measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
Okay, so let's pull out our information. The normally distributed. Okay, the standard deviation is known.
Mm-hmm.
So it's going to be one of those earlier tests.
Yeah, so let's see.
Okay, so the null is the mean is equal to
Equally.
1.5. Okay, and then the okay. Okay. So alternative hypothesis to okay, so we're using this hypothesis, okay. Yeah. So the alternative is the mean is greater than 1.5. Okay. So at the 0.5 level of significance, you would conclude that
Would you?
Wow.
I don't know if they want us to actually run a test, but
Let's
just
see.
by looking.
Would you do the? Let me see. What did I do here? It looks like. Let me check. So. Let's see.
I'm halfway through. A while. What do you need?
So how long?
Another hour?
I gotta call. What do we tell them?
We've applied for it, and it'll probably, they said 1 to 2 business days, and it started in 1 day. So it'll probably be another day, and then it'll be in the system. We have our duds now. It's just not in the system. I got it.
You said something about percent.
Yeah, I have to wait for it to get in the system to finish
Percent.
doing this. But I've applied, I've got it. I've plugged it in. I'm waiting for the DENS number to be in the system. Okay. Okay, so the different hypothesis tests are, I had that, remember we filled out that homework, it says different tests. Well, it says
I'm guessing.
higher, so you would reject the no.
Wow. Do we have to?
Are you thinking we need to plug it into a phone?
Yeah.
Because there's basically the only formulas we could do. Okay, we can't do the others that use the computer, use SPA. There's not enough data.
Mhm.
The other ones we could use is the we'd have to have the z-score to do one.
Yeah.
To go. So I don't think we need,
Because
margin of errors. We'd need the sample size. We're going to put it in a formula.
because I think I tried something. I don't know if it's right, but I did the formula, like the test statistic formula. So z equals x bar minus mean divided by standard deviation divided by the square root of the sample size.
What's that formula? Z equals what?
Z equals x bar minus the mean, like the mu, divided by the standard deviation divided by the square root of n. So let me see if you can see. It's like,
Is that in lesson 9?
yeah, like that one.
Yeah.
And so then I plugged in the
Can
numbers,
you that?
and then the answer I got, I put it into the applet. And then just kind of determined whether it was smaller or greater than the 5%.
So, and 5%, did you put it in the applet to show what that was? Like, how do we know what 5%?
Well,
What is the 5% of significance?
I was just asking, like, is it lower or greater than the 5% level of significance, which is what, 0.05? You know how they give us, usually the level of significance of 0.05?
Yeah.
So it's just whether it's greater or lesser than that. So I don't know if you kind of want to do that formula and plug it in and see if.
Okay, I'll do it. So X was 1.5
minus 1.5
0.17 divided by square root of 100 is 10, isn't it?
Mm-hmm.
So did you get 1.764 or
Yeah.
1.765?
Mm-hmm. And so then what I did is I went into the applet, put it down in the z-score boxes. And it would be, let's see. So you would shade.
What?
Would you shade both ends?
Yeah, if you get that's important.
Because it's saying it's equal to, or
Tell me the link for the app.
Oh, let me see. All right. I sent it to you.
Oh. I have it saved in my bookmarks, but it's not. Okay, BYUmath.com. Okay, so we're trying to figure out which side to fill in.
I think it might say it in lesson 9. Oh yeah, because you see in lesson 9 how it gives different options.
Different options
of kind of give you like the applet, and then it tells you if it's two-tailed, left-tailed, right-tailed.
Yeah. Right.
Yeah.
So. Okay. Yeah. So if the text will be greater than the left-tailed.
It would be the left-tailed.
That's what the hypothesis says.
Let me check.
The mean is greater than 1.5. Right-tailed. It's right-tailed.
Yeah, right-tailed. So then that's what we would highlight, right?
Yes. Okay. What?
1.765. So then wouldn't in the area box, wouldn't that be our answer?
P-value. Yeah. So it's
and then divided by 2 because it's one-tailed.
Yes.
Let me check.
Wish this was multiple choice.
I know.
So I got
Okay.
0.4806.
Yeah, that's what I got.
So that p-value is smaller than the 0.05. But
That's greater.
at the 5% level of significance.
Yeah, the 5% is 0.05.
Oh, okay. All right. So the answer was
0.4806.
so it's smaller. So we would reject the no.
Yeah.
Okay. So because I was just looking at this, I don't know. That wasn't right. I was just looking at the sample mean of all of those 100 cigarettes was 1.53.
Mm-hmm.
It's higher than the 1.5.
Yeah.
So, well, it's not the same, so you do. But yeah, we probably needed to do this equation to get it for sure.
Mm-hmm.
Okay.
Wait, is it? Because 0.48 is greater than 0.05.
Oh yeah, I see 0.04. Okay,
So we failed to reject.
you're right. Oh. Okay, you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. This is the procedure. Okay.
Would it be independent sample test?
So the paired sample, that's the one where you're comparing the same.
Yeah, the paired is where, like, it
Before and
depends.
after,
Yeah,
pre
like,
and post.
yeah, like group 2 depends of group 1.
Okay. So we're looking at the hours. You're testing each group. So
Yeah, for
I
wages.
would think independent sample.
Yeah, independent sample t-test.
Okay. So an educator is interested in an academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. She would use a hypothesis test based on independent and dependent samples. So she wants to know if males and academic achievement by males and females are similar.
Mm-hmm. Would it be dependent because it's it's like brother and sister pairs?
Yeah. Sister's academic achievement depends to some degree on the brother's academic achievement. Or if you select a brother so as to compare his academic with sister, you must include the sister in your study. I think it would be the last one.
Yeah, because you need the sister to compare the brother's scores.
Okay. Okay, so soil scientists collected random soil samples from a field and measured the dissolved organic level in each sample. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Okay, so we can identify dissolved organic carbon.
Come in here.
See.
Yeah.
Hey. Hey, come on.
So what is it? The dissolved organic carbon.
When I say Axel.
I gotta find.
Hey. Hey. Ah!
Okay, I'm opening it up right now. So I guess we can, while it opens, of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
Yeah. Oh, I wish I'm trying to find the data files. Got them in my bookmarks.
No, he's signed up. Come here. Come here.
Okay. So it just be just the normal confidence interval for you when sigma is unknown.
Does it say whether it's known or not known?
Yeah, that's what I'm thinking, because I mean, it can be known if we just figure it out through SPSS.
Okay. Well, okay, what are we doing? We're measuring the organic carbon levels in each sample.
Mm-hmm.
Are we comparing anything?
No, it's just.
So it's either 1 or 2.
Mm-hmm. Because it's like I said, right now in the question, I mean, it's unknown, but it can be known if you just plug everything into SPSS.
But I think we better do it as unknown, because when it is unknown, that's when we do the S.
Oh, okay. B. Okay. So which of the following is the 95% confidence interval for these data? So,
Oh, yeah, but no. What she said? Pero van a cambiar.
$10 a que no cambia. Que quiera cuesta. $10.
Wait, you don't have $10. ¿No tiene dinero?
So I got D, was the last one.
Okay. Let me see. So what you did to do that was
I went into
you analyze.
Yeah. And then to descriptive statistics. And then into explore. And just got it that way. Yeah.
Okay, well, let's. This is something I can't read to pull out. Let's read this. I'll start that and come back to it.
For
Stairs, go.
for
Let
which
time
one?
read this next. Open up the other file.
Oh, okay.
I'll just. Oh, it's trying to open now.
Let's go. Oh, because you got the bar.
I'll just read it and see what number 17 would be. It says a random sample of Hummers for sale in Los Angeles, New York were taken from listings at cars.com. We want to know if there's a difference in listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in Group 2. Rating for the mean listing price. Okay, so it's a B.
B, yeah. B?
I'm thinking B because I don't need individual data for one group isn't relying on the individual data for the next group. So it'd be the independent samples.
Oh, so you said D?
Yeah,
Okay, that's what I got. I thought you said B, so I was reading that one.
yeah, neither one of those.
Okay, yeah. So then, which of the following is a 95% confidence interval for the true difference of mean listing prices between Hummers for LA and New York? Okay.
Okay, I'm at the carbon levels. Yay!
Oh, thank you.
Oh, okay.
Analyze, descriptive statistics, explore. This is all they say to go to explore all the time for the confidence intervals.
Yeah.
Oye, vamos.
So yeah, I got the last one.
Okay. Do you think we'll need the applet anymore?
No, I don't think so. No, we shouldn't.
Okay, fine. Ya, no, Corey.
¿Sí quieres ir?
Ya.
Espérame, déjame comerme otras tortillas de niña. Oye, que valga la pena ir al gimnasio.
Y luego vamos a McDonald's.
Pero ¿qué voy a hacer yo? O sea,
¿Cómo que qué ibas a hacer
no,
tú?
mira, de tiempo que no voy, porque ando allá, que me queda estresada, y luego tengo mucho trabajo. No sabes cuándo trabajo tengo. Estamos saliendo hasta las 6.
No me digas de trabajo, yo trabajo.
No, yo trabajo más. Me voy tempranito, me da hambre. Es que con el doctor que estoy ahorita es demasiado, mucho.
Okay, not doing this. Oh, for this next one, oh, this make me upset. Can't get this figured out.
O sea, si no se fuera un doctor.
Ya.
O sea, como si fuera un
Oh, you want to just go to the next one?
doctor.
Yeah. On the cars one.
No, I thought he
Me
had
hablan ahorita, no,
answer.
no es mi computadora.
Pues, no tengo la
Because I'm a little confused on this car one.
Okay. As long as you're working, man, I'm not waiting on me. I'm still trying to get this to work.
No, you're fine. I'm just confused on this one.
What is that?
Mhm. Sí.
I was up before that. Your daughter.
Okay.
No, we making excuses. You're making
Have you
excuses. Why you
been
have
able to
my
open one of them?
Well, I've got the Hummers open.
Okay.
I see you. I
Okay,
see
so that one, we're looking at the
Charlie.
price
Mm-hmm.
between the different cities.
Yeah.
So you'd have to recode it.
Mm-hmm.
Okay, so go to automatic recode. We're gonna recode the city.
Yeah.
Okay, and I'm gonna put new name, city code, add the new name,
Mm-hmm.
and okay. For some reason, the organic dirt one or whatever didn't work. Okay,
Okay.
so we got the city code now. Okay, so now I'm gonna go to analyze, compare means for independent samples,
Yeah.
t-test, or would you go to the or
Just independent samples t-test.
okay, so you're testing the price.
Yeah.
The grouping variable is the city code.
Mm-hmm.
Okay, and define groups. 1, 2. Okay. Okay, so this is, I don't know if it's just slow, but it's doing the same thing with my other tests. I put all my information in, and it's supposed to bring up the picture window,
It's not.
and it's not. I don't know if it's just, I just need to wait. It's frustrating. Like you get my program would work. Whatever. Okay. I guess Liam can tend the baby.
Maybe you've been in the house.
Okay. I'm gonna close my SSPS app completely.
Okay.
Sorry, gotta have this thing to do. So.
O se aprenden así por online. O se aprenden así por online. Porque no tienen que hacer prácticas, todo eso.
Okay, so the one you were working on.
Yeah, for the cars one, the 95% confidence interval, I got -423 and 5417.
Oh, did you? I thought you marked the last one. Was it the last one on number 16? Is what you got?
6.
Or not 16? It'd be set. If the 95 confidence interval for the organic carbon.
Oh, I got the last one.
Okay. And you got C for this next one.
Yeah.
Is that one you're having troubles with?
I was, but I think I figured it out. So yeah, it's too bad. Yeah, because that's what I had. That's what I got yesterday. So
Sí, para no complicar. ¿Me quieres regalar unos tenis exactamente como estos?
Todo lo tendré en cuenta para otro año.
Okay. So tell me,
Mira,
I've brought that up, and once I bring up the one independent sample test, it should just show the 5.
Platos ahí, ¿no? Para...
no, yo digo nomás para que
That what you did for the 35% interval?
are we what? Sorry.
Se los dejo, si acaso habla la hermana Shah.
What was that, Sadie? I couldn't really hear you.
Oh, can you hear me?
Yeah, now I can.
yo voy a dejar el, pero quién sabe si ella me va a la hora.
It's opening my program, so voice, I think.
Yeah, it kind of cuts off in some parts.
Okay, so I was saying how I opened up the and then the data that should bring up should have the confidence interval in there, right?
Yeah.
Third.
Oh, I'm about ready to throw a rock at this computer. I'd be done in 5 minutes if it could work.
You're so spoiled. He was white. Daddy picks you up and you just like that. It's not. It's not.
No, Andrea, aquí se va a hacer una palita, apenas salir.
Did that, did that.
Down, down, down,
Weapons, you should.
go down. Yeah, keep coming. Keep coming. Come on.
Este alérgico al deporte.
Vale. No tiene por qué.
Yo hago ejercicio mirándolos.
Y hablando aquí.
¿No se va a isla?
Done?
No.
Si camina ya con su brazo.
There you go.
Isla.
Daddy beat you with no. You need to sit down. Let me see if he'll let you hold it.
¿Tienes one follow, Carlos? No.
Oh, a ver, creo que ahí está uno arriba. Pero es ese. Sí, o acá, mira. Acá. No, esos son los martes. Ya es. ¿Cuándo fue? Martes, ¿verdad? Y yo tengo que la casa. Ya, fue martes.
It's okay.
Is it not working, Sadie?
Can you hear me?
Yeah.
I can hear you. Okay. Have you done the whole test by now?
Mostly. Yeah, I'm just like checking the answers I got yesterday.
You're checking the answers for what?
The ones I got yesterday when I worked through it.
Oh, it looks like our only options right now is we can wait forever and ever and ever and ever for my thing to work, or we could end our Google chat
Yeah.
and come back on and try it, or just end it and work on it by ourselves. Because I think with the Google chat on, usually when I do this, I load SPSS first,
Mm-hmm.
have it ready to go. Because when I try to open it while we're doing this, it just is too much.
Yeah.
So it's up to you.
Yeah. Well.
If you want,
Yeah.
I
Because
could.
because I could like tell
If
you.
you wanted to turn it off, huh?
Yeah, because I could tell you the answers I got, and I mean we could just kind of do it on our own, and you could check if you got the same or something different, or.
Okay. And then before we submit it, or just submit it.
What was that?
Can you hear me?
Yeah, now I can.
So I was saying, do you want to just submit it? Or do you want me to get off of here and go through it and check it and then compare it again and submit it? Or what do you want to do?
Yeah, it's up to you because I could give you the answers I got, and then you could check it, or yeah, it's really up to you.
Okay. Well, let's just, I'll try to work them all myself.
All right.
Do you want to meet like at 11? Do you want to meet back at 11?
That's
Or
gonna be kind of hard, yeah.
Okay. You tell me what you'd want to do.
I think I'm just gonna submit mine, and then
Okay.
I can let you know how I did.
Okay.
Yeah.
So I could probably, okay, so like for number 18, there was 3 groups of rats.
Yeah.
Between the, okay, what do you use an ANOVA test?
Let me see. For number 18?
Yeah, or 20 year. Says what is the correct?
Oh, the ANOVA one? Yeah.
Okay. And then, so what did you get for your p-value?
I got 0.002.
Okay, so that's low. So that means there's numbers for 22.
Mm-hmm. So it would be, so yeah, 23 would be B.
Is it the same?
Okay, yo voy a la iglesia a dejar todo eso, ¿eh?
Venimos 2 horas.
Oh, okay.
No, puedes hacerlo.
Oh, no.
Okay, yeah, 'cause one of them's different because we rejected it, so one of them's different. Okay.
Mm-hmm.
So this airport, let's see, airplane tickets.
Yeah.
90 days. Okay, so this is a pre and a post one, so it'd be the matched pairs.
Yeah.
Okay. So what'd you get for the p-value on that one? You could answer the next one.
For 26, let's see. I got the p-value 0.096.
Okay, so you'd fail to reject the null. So there's insufficient evidence.
Yeah. So it's smaller.
E. E for
Yeah. Mm-hmm. Yeah, so I think I'll submit it. I'll go ahead and submit it to see what. Oh, we got a 96 on it.
Huh? What'd you say?
We got a 96 on it.
A 96?
Yeah, 96% on the quiz. Because I submitted it already. Yeah, so I don't know if you just kind of want to work over them.
Yeah, I'll just do that. Because like I say, once I get that thing open,
Yeah.
and you telling me what the p-values were, we were able to answer those other questions.
Yeah.
I'll get that open and get that data.
Yeah.
Sorry, you're waiting on me. What a bummer.
No, you're good. Yeah. So, good luck on your exam.
Okay, you too.
All right.
Okay,
Yeah.
we'll see you Tuesday.
All right.
Okay, bye.
Bye.